As we already got introduced a bit in the chat, but I'm Marek Alliksoo of SkyCorp, and we're going to be talking about hydrogen drones in remote sensing, but also on a wider scale, and I'll actually try to go hydrogen on a wider scale as well, because it's a much wider topic than just drones, and I think aerial data is no different. You have different capabilities in terms of flight endurance and your flexibility and your operational capabilities, but the data, they're just tools anyways. So the sensors that you have to attach to gather data are the same as with anybody else. But let's kick off with a small introduction on who we are. We're a relatively young company, actually, from 2017. And we stumbled upon hydrogen not because it's green or carbon neutral or any of that stuff. At that time, it was a problem with flight times, and that was the only solution for us. So we accidentally ended up being the first company in Europe to make a commercial hydrogen drone, and we launched that officially in November 2018. This selection of events listed there is, of course, a really small one. But obviously, we've had to go out to a lot of places and talk about it. And safety, of course, is always the first question, which actually has started to dissipate now, where hydrogen mobility and applications have become a lot more widespread and actually more talked about. Because as you may know, then hydrogen fuel cells were used already in the 1960s to get Apollo to the moon. But yeah, it's not really that common of a topic, let's put it this way. And of course, because of those activities, we've had to join a lot of different associations, consortiums, and groups, and all of them have been in one way or other useful for sort of generating that awareness and helping with the regulatory clearances of the industry as a whole. And of course, this year, we're also now part of the European Space Agency incubation program, which I'll get to in a bit later as well. But overall, I think you could sum up our mission as creating a carbon neutral autonomous environment of these drone-based services. And hydrogen there has been an enabler. And let's go ahead and talk how it is an enabler, because there have been a lot of enablers, especially recent times being added. We have carbon neutrality targets now European-wide. We have a strategy even for that, which sets those targets to be completely carbon neutral by 2050. Strategic value change in autonomous vehicles and hydrogen and carbon neutral industry, for example. IPCEIs, which are important projects of common European interest, Green Deal, Clean Air or Clean Aviation, and of course the Clean Hydrogen Alliance, which is supposed to unify a lot of these hydrogen-related activities in a massive array of industries. On the aerial side, we have finally started to see simplifying of the regulations that are different from country to country. In the UK, when we launched, we were told that it's fantastic, but we can't use it. Like, we have to land, walk to the other side of the road, and then we can launch again because we can't fly above the roads. Ordnance Survey, their sort of land board, I believe, has an exception to this. Usually you have to be 50 meters away from the road before landing. They have 25 meters. So what are you going to do if you can't use the technology? But from the end of this year, the first set of regulations go active, which should unify the European regulations and set some standards and a common, for example, flight height even, which we previously haven't seen, because every country has a different one, which actually Estonia has to pull back from. We have 150 meters at the moment, and now it's supposed to be 120 meters for everybody. But at the same time, in Belgium, it's 90 meters. So I think it's good to be at least having that know-how already in advance on what you can do in different countries, and that helps. And of course, we've been building and experimenting with a lot of those more advanced use cases and finding out what the sort of return to investment in scenario A or B or C would be, and what was previously limited or not possible, and how can we enable it now. So a really exciting time to be doing all of that. And as you probably know, at least everybody in the drone industry, the main problem is short flight times. You have 20 minutes, so what can you do if you're above water, if you can't land? If you want to send a shipment somewhere and it's 40 minutes away, what do you do then? So there's a lot limited with that. And back to the regulations, the guy on the right there with the helmet, I don't think we've been helping our own industry, making it feel like it's somehow ultra dangerous to be doing these activities as well. And of course, because of those limitations, we really can't compete against manned aviation, having to take a helicopter to do that survey, or just doing things on the ground instead. And of course, LIPOs have their own additional problems with IATA regulations, which are flight regulations. You can't go over 99 watt-hours without special clearances. So if you have a larger system, you have to send your batteries by land, and that's a hazardous delivery, and you end up paying a lot more even than by flying. Incidentally, hydrogen doesn't have those limitations if you release it from the tank, because it's a compressed cylinder otherwise. So the common ones apply to us. And that holds back from large-scale aerial data collection primarily, because satellites are great, but you lack the resolution. Helicopters are great, but it's quite expensive. It would be great to replace that with drones to the full scale. But yeah, we've been kind of limited there now. You of course have different options available, but they have their own issues. And we've been talking about logistics now a lot these days, aerial logistics. We don't have traffic in there. A lot of people seem to forget that. So if I say 10 minutes, it's always 10 minutes. Better monitoring. We're talking about risks of wildfires, flooding, erosion, different incidents even that can occur. And of course, especially now when we have this pandemic situation and at the same time global warming, we have all of those issues piling up that we could be actually solving a lot more efficiently. True humanless actually interaction is possible with drones, because if they're in the air, they're operating autonomously already. It's not like self-driving cars where you have to somehow predict what the unpredictable human is going to do and then hope that the car can compete with that. In the air, it's not going to be an issue unless actually you have a person flying in the same airspace as you, which especially in our region really isn't an issue, and there's ways around that as well. So in short, battery technology limits us from exploring these use cases. And manned methods are still the king in the area. And of course, we need to make them more automated and also self-sustainable to be exploiting all of the opportunities we have. And let's look at sort of the future scenario now, or what we can start doing. As mentioned, the regulatory clearance is a huge help. And of course, our region has been innovative in this case. Our regulations have not been prohibitive, actually almost at all. During the pandemic time, we were flying for 2 weeks straight in the Tartu city center. We of course got a really easy clearance as well, because there's no flights coming in. So just ring up the airport. Maybe there's a medical shipment, but other than that, to do what you must. The technology is actually really mature. It's the question of maturity on a really small scale, because it's not commercial, it's almost handmade and tailored. But technologically, it's been used for 100 years, and fuel cells themselves for 60 years, basically. So we've all been there, it's just a new application. Again, the framework, European use space, which should be connecting up ATM and UTM, so manned and unmanned aviation. Again, making this crosstalk vehicle-to-vehicle type situation almost to enable, again, airspace above cities, close to airports, areas which might see higher traffic. We have the same neutrality targets, carbon neutrality. I think it's boosted drone use a lot more even, because that can alleviate traffic on the ground and reduce those emissions and congestion. According to reports, about 70% of the packages, for example, from Amazon are below 2 kilos, which is an entirely viable range for drones. So you could, actually Amazon has said that they will need about 14,000 drones, and they could take up that 70% range to an extent at least. And of course, everything is going more autonomous now. Cars, drones are there already. Systems in general response should be autonomous where possible, or at least automated. You have to help and assist the human, not make them do the dirty work. The dull, dirty, and dangerous parts is what we should be reducing. There's a lot of extra focus now on increased applications and integrations for satellite data. A lot of companies that we see, I think a few weeks ago, Capaceta was talking about their applications in the precision agriculture field. And it's a combination of all of them. And as I mentioned, dealing with all of those global disasters and problems that we have to be a lot more flexible. We don't have the opportunity to plan 2 months in advance. We have to be there tomorrow if needed. And there's a demand for long endurance, rapid operations, automation, all of these things for a lot of these topics I've listed there, and that's not a conclusive list. I think the most conclusive list was released a week ago from a survey we took part in as well, and I saw about 36 applications listed there in total for drone activities. So let's talk about fuel cells. That's the most difficult graph I'm going to present, I promise. What we use in particular, and what most of the industry is using now, are proton exchange membrane fuel cells, which is actually a fairly simple system because you inject hydrogen and oxygen from the anode side, and you have electricity and water coming out from the other end. There's a chemical reaction going on, so the hydrogen proton passes through the membrane. The electron has to take the long route, and that creates the electrical circuit. And the fuel cells themselves can be very modular because I'll be talking further about it in the next slides. The range goes even smaller than 500 watts, but when we're talking about multi-rotors, which are basically lifting themselves up there, they're not fixed wings which get additional support. So we have to start from at least 500, 600 watt systems. You can go above 3 kilowatts as well. But as a rule of thumb, you have to consider that unfortunately on the small scale, the technology is still quite expensive. So for each kilowatt, you basically pay €10,000 price ticket initially to get access to that. It's a hybrid system for several reasons. You have to negate your peaks. Otherwise, you have to go a bigger system, which again you can do, but it's more costly. So why not use a battery for that as well to have your peak load? You also use it as a backup when needed. Either you forget you're running out of hydrogen, or if in case something happens, you have actually more redundancy on a hydrogen hybrid system than you would have on a battery system. You have storage from 1.5 liter tanks to 10 plus liters. The pressure is commonly at 300 bar to 350. 300 you can actually get just basically off the shelf. We partner with Linde, who introduced their Genie range actually on our request also to Estonia. So we used it previously in the UK. And you just refuel with pressure equalization. So what you end up is a total system, which is basically 500 plus watt hours per every kilogram. It's the common range is 700, which is 3 times as power dense as a battery system, where 1 kilowatt hour of energy is 5 kilos of weight that you carry. And that weight doesn't go away when you deplete it either. So the really big difference is that you separate power and energy. So power is how much you can move, how much weight you can lift, for example. And the energy is how far you can move it. So with batteries, you have it all together, and you increase both. Even if you don't need more power, you still increase your weight there, and that's always equalizes the entire system. You don't get more flight time just because you had more power or batteries necessary. And in a fuel cell system, separate. You have your power, which in our case, for example, is an 800 watts module. And we have our energy, which is, let's say, the smallest unit is 1.5 liters. But if we want to double our flight time, we basically just double the cylinder. And that's a 3-liter cylinder. That's from 1 hour to 2 hours, because the weight actually increases just by 600 grams. As you have all the construction is the same, you just extend the cylinder itself. And this gives you a lot of more dynamic power in terms of customizing and building your system. Your other advantage, of course, come from the lifetime. As I mentioned, the capex cost is always high, but your overall lifetime OPEX cost, just the system alone, already equalizes out, because batteries are not cheap as well. If you think DJI batteries are 160 to 200 euro per battery, and depending on the drone, you need 6 of them. So your set is already in thousands, and your lifetime, on the other hand, is maybe 80 useful hours, maybe 100, 120. So you go through a lot of sets of batteries before you do even need any maintenance on the fuel cell. You have a really wide range of operating temperatures, of course, in terms of the external one. Internally, you're actually at 40 degrees. The external sort of signature is about 20 degrees. Depending on the fuel cell system, if it's a contained one, basically you can operate in minus 40 to plus 50 easily. If it's an ambient cooled one, so it takes the outside air, then of course your operating range is a bit more limited in terms of the cold side, because dry air actually, or cold air is dry and it dries the system. Fuel cells like to be about 50% in moisture. So actually some small rain is really good for the system. Otherwise we need to moisturize it manually. That's a technical side, which would need another hour at least to explain fully. But at least we also don't introduce any vibration or noise to it, because it's a chemical process. So there's no moving parts other than the ventilator that's pulling the air through the system to provide the oxygen for the system to do its reaction. The environmental impact is actually reduced. I read an interesting figure some time ago where there was a question of, okay, where do we get the platinum if we want to make all the cars electric, fuel cell electric? And the platinum in the cars, for example, is pretty much the exact same quantity that you'd need for a 100 kilowatt fuel cell. So you can replace them 1-to-1. And that's the most expensive component in terms of rarity in the system. Whereas LiPos have, of course, lithium, but also other hard to find or mine substances that still can't be properly processed. So you have maybe 75% maximum efficiency. And you don't really want too many LiPos lying around and piling up, especially because, again, they can cause a chemical fire, which is why they are restricted regulatory by regulations in the IATA ASPERS rules as well. There's no voltage drop, so when you consume hydrogen, your system is always outputting the same voltage. As you know, with batteries, your voltage starts dropping. So you start maybe at 24 volts, and by the end of it, you're at 19, and then you should be stopping, because if your voltage goes too low, you risk damaging the battery. You have to store them at voltage temperature, voltages, certain storage voltages, and that's another common hassle that we've been hearing about. We can leave our system hanging for however long we want, really. It doesn't matter then. As mentioned, then refueling is pressure equalization by default. I think the next slide or the slide after that will show a picture of what it looks like. We don't need electricity to do it. It's quite fast. And all of that together, of course, gives us that advantage of being able to retain a compact size because we're efficient in our energy storage. Right. And that's, in conclusion, the key advantages are endurance with longer lifetimes, fast and easy refueling, and the worldwide target technology of being green. And overall, that translates to about 10 times larger coverage area as well, because you go in all directions. And you can start replacing those manned options that we talked about in the beginning, because that's about the operating range that you'd usually want to have as well. If we think that we can travel 80 kilometers an hour, well, that's roughly the range we could go then, if you don't have anything too heavy under us, because we can fly for up to 2 hours. And that's quite an advantage, although you'd like to probably keep it in the 30 to 40 kilometer range to also account for the unexpected here and there. Oh, and that's our refueling setup. That's nice and simple. On the left-hand side, you can see our Genie cylinder, which is 424 grams of hydrogen. It doesn't sound like a lot if we think that a Toyota Mirai, for example, a hydrogen fuel cell car, has 5 kilos of hydrogen. And for cars, 1 kilo of hydrogen is basically 100 to 130 kilometers of range. So it's quite easy to calculate. But that one Genie cylinder has 14.12 kilowatt hours energy in it. And our consumption is 30 grams an hour on average. So our energy carrying capacity is very compact. Just taking it out to the woods with you, and you can just be there the whole day using up all the available daylight hours that you need, and then come back in the evening, take a new one from your nearest gas supplier the next day, and you're good to go. If you need to do, I don't know, 16 hours or more straight, you can always also, of course, use a compressor, in which case you can take every last drop of hydrogen from that bottle. But so far, it hasn't been really necessary at all. And it's not that much, I wouldn't say it's competing with all the systems. I'd like to say it's more of a complementary system, because hydrogen drones or any other technology is not a solve-it-all sort of silver bullet, but it can help you achieve those targets that you might have depending on your application, depending on your challenges or your previous problems. So what it does help with a lot is lowering the operating costs and having frequent operations because of that. Because you can now use, instead of a manned application, you can use a drone. That helps a lot with those applications. It is really flexible, of course. That's the most flexible option. And you have that high spatial resolution that comes with your sensor side, of course. But now you can take full advantage of that. It still is more acceptable to have smaller payloads, so less than 2 kilos. 1 kilo is the ideal range, or lower than that, of course. It doesn't mind clouds. It does mind rough conditions, so you can't replace satellites, that's for sure. And there was an interesting study, the link is below as well. It was about the UAV aircraft and satellite remote sensing platform comparisons in the Brazilian viticulture, so wineries. And it listed 2 problems for UAVs in being fully competitive with the other systems. One of them was the limited payload, and the other was the limited flight time. So if we can remove one of them, that's a huge benefit already. And that means that we can go into these higher integrations, as I also previously mentioned. We're talking about better response to our nature. And a lot of that we've caused ourselves, of course, but let's try to now mitigate it. We can better coordinate around these multispectral data sets, or any data sets really we get from satellite applications, to provide this ground truth. For example, one of those cases, if you're doing precision agriculture and your plot of land is really narrow, and then there's another culture next to it, also really narrow plots, and another, then what you want to do is maybe you can see the wider problem from other remote sensing data, but you need to pinpoint where that exact area is, which crop is causing maybe the issue, or which of them is malnourished, or which of them has a potential disease. So you work in tandem with those other applications. And of course, satellite data is dependent on the certain time or date when you have the next pass over that area, so you can be faster in as well. Some other use cases. On the bottom left-hand side, you see something that was previously very limited, and that was offshore inspection, or really any offshore activities. Because once you fly out there, if you really can't land and put on a fresh set of batteries, then you're done for. And hydrogen fuel cells and hydrogen drones, of course, enable you to actually be useful on site as well, not just go there and come back straight away. Of course, some larger drones can stay for a bit longer, but again, how many trips do you have to make? A lot of people tend to leave the man-hour and the man-hour cost out of the picture. And I think the comparison on the right-hand side also illustrates it. It, of course, depends on country. But if you have the same area to cover, and you can do it with less equipment, less man-hours, less refueling points, so less driving between different points as well, then that's a huge advantage. And this doesn't even take into account like hotel costs, for example, or the benefit of being able to finish your project faster. So instead of a week, you maybe just spend 2 days on site, because you can use all the daylight you have. If you have a perfect day, with sun is out, so you get really nice flat equal data, then you should be using all of those hours that you can. You might not have a good day the next day or for the next coming week even, and this can cause you a lot of issues. So yeah, aerial data, we all love to see that. Added some pictures from familiar spots from people in Tartu, hopefully. But yeah, as I mentioned, it doesn't matter. It's a drone, a hydrogen drone, a helicopter, a satellite. They're all tools. The sensors you attach to them makes them useful, and that depends on what you need to see. But let's talk now a bit also about the vision, because this is where we can mention a bit on the European Space Agency incubation project as well, because this is just the beginning. This is really just the beginning. What we see ourselves is a three-phase approach that we should be taking. And the phase one is what we started to complement, because now that we can be really useful in there, let's also be truly useful when we're not in there. So let's make those drones self-sustainable, self-managing, so we can leave them out in the middle of nowhere and be able to run them from all over the world without having to have a person on site. This, of course, needs infrastructure on the ground as well, and that's the phase two, to have this hydrogen drone hub that can use either solar or wind to generate its own hydrogen. So it can be completely off-grid. It can automatically and autonomously refuel the drone that lands there. It can send all the data you need. You can integrate it with things like Copernicus data sets, for example, to make them give you alerts about the area that you're in and the potential things you should be looking out for, and be more proactive, because drones shouldn't be just doing one mission at a time. This was only because we could be doing one mission at a time, because we had just 10, 20, 30 minutes to do something. So yeah, we can't be really doing too much then. We should be concentrating on our main mission that brings in the money. But now that we can be there more, and what we're looking to do, of course, is make them a completely automated system, we should be collecting multiple data sets at the same time. And that's where the fun starts, because now we're looking at a multi-layered system that can support everything. And instead of looking up a provider somewhere or negotiating the time of the day and then remembering that you're in Germany, they can't come out on a Sunday because of working laws, and on Monday I can't be there because I have something else to do, and then you have an appointment in 2 or 3 weeks time only, and then you finally get your construction site survey done that you needed 3 weeks before. And all of these issues, we should just be able to log on to a website, select our area or where we need to do some operations, set our parameters, our requirements, and just wait for the data to land in our inbox. That should be it. And this is possible to do. And I don't know why we listed so few here, but the value add possibilities are actually endless. In addition to air quality or traffic data demographics or things like this, and predictive analytics data sets, of course, we could be running multiple missions at the same time, because if we're talking about launching from drone hubs, not the person physically coming to your property to set up and then do the job and then go away, if the drone starts from maybe 20 kilometers away, it's flying to your site to do the project that you required. While it's flying away, it could be also surveying the power lines, or taking some measurements for precision crops, for example, what the moisture quality level is, or monitoring infrastructure. Predictive maintenance for example, road works is an important topic. If we can start automating these things, we can contribute also more towards things like digital twins of our surroundings. So this is where we enter the field of, let's fully remove the dull, dirty, and dangerous parts of our everyday lives. Let's concentrate on the creative, innovative side, the thing that machines really can't do. Let's leave more time for those activities, and let's take advantage of all of that. Let's exploit the system. And here's a quick example. For people that think it's really difficult, then unfortunately, I hope I'm not shooting ourselves in the foot there. It's not really that difficult at all. We did this in Taltech's Energy 2030 workshop. Actually, our engineers set up they had a battle bot, and they converted it to hydrogen in just some 20 or 30 minutes. It was very fast. And they were riding around with it, so it made for a perfect COVID or zombie outbreak-proof mobility device. It, of course, extended the range. So during the hour it was running, it was actually just consuming 9 grams of hydrogen. If you think of the kilogram price, I think in Latvia, where we have the closest hydrogen refueling station, the price there is about €7 per kilogram. So you can calculate the price of running that little workshop and that little demo there. And on the left-hand side, you can see the 3 main components as well on top of that battle bot, the fighting robot. The fuel cell is on the back side there, the little metal, shiny, small piece. You have the hydrogen tank connected up to it, and connected up to the fuel cell, you have that small little hybrid battery that provides the startup voltage, that can provide for peak voltages, that can sort of extend its time, and that acts also as a redundancy device. So this isn't the only thing we've been asked to convert to hydrogen, by the way, as well. And hopefully we can make some of our plans of our own hydrogen Cessna true as well in the nearest future. Because it's not really that hard. If you have an electric system, you just replace the storage in principle. That's all you need to do. And this is a good time for a poll, because I want to do a bit more of a informal one. in terms of that. And I don't know exactly what's the most interesting part for you, because in remote sensing, it's really a tool. The output is the same. It's a tool that helps, but perhaps I should be talking about hydrogen wider. So I've listed 4 topics that sort of came up that you might have questions about. Would you like to hear more about hydrogen mobility, aviation integration, hydrogen in Estonia, maybe, what's going on? Hydrogen programs from Europe side, resources, funding, projects, or also the EU roadmap, regulation, legislation, strategy. So let me quickly start the poll. While you vote, I will take the question I saw in the chat as well. Right, I think you started voting now. Let me see. Okay, hi Matthias. How many cycles, right? Yeah, 500 cycles with batteries would be a really good result, actually. But the fuel cell, we have a manufacturer's warranty for 1,000 working hours. But the estimated sort of lifetime, the average, because it's not a fixed rate, so you eventually just start dropping a bit on the efficiency, and that usually starts happening around 2,500 hours in. It could be less by a bit, by a few hundred hours, but it could be also more. For example, in the automotive level, you have fuel cell buses that have been driving like 2 or 3 times past their estimated lifetime. So it's a lot harder to measure for, but you at least can set the minimum time, and you'd expect to see about 2,500 commonly hours of work time from your drone, which I think is a lot of flying. Yeah, the battery full and discharging time cycle was again a problem. We don't have that with the fuel cell. When it's been standing in dry air for, it's usually said 100 days, but it could be less, like we've seen from when I've been traveling with it, coming back from airplanes. Then those environments really like to dry out the fuel cell, so that when the plates are dry, it isn't as efficient. So your power output is less. So what you need to do is kick it hard, like maximize it for some 10, 20 minutes. Of course, you can do it also in the air if you want, but you have a sort of a power load unit which introduces big loads on the fuel cell, which it likes to work properly. It doesn't like just idling by doing nothing. So that unit sort of stresses it, and within 10 minutes your maximum or ideal output is there. But usually the preferred storage condition is 50% humidity and about 20-degree temperature. So yeah, our ideal climate really. Yeah, so there are no cycles in that principle. You have working hours, and the more you stress it, the better it is actually for the fuel cell. So feel free to add any other questions you might have. I think I'll leave the poll running for a bit and then see what it's about. We have about 2 kilo as the payload capacity. We actually introduce sensors of our own. Onboard computing, of course, is necessary. So whatever you can connect up to it, the more efficient it becomes while it's doing things. We want to do stuff like onboard processing, for example, because if you're collecting data for an hour straight now, then yeah, after an hour of waiting around, you suddenly have a lot of data on your hands that you have to start processing. So it would be quite handy to get some of that data done already while it's doing its job. So we want to add also some additional support sensors for that, for example, air quality, and whatever smaller ones we can fit them to make them more useful on the multi-mission layer as well. Okay, the poll is quite tight. Some folks still need to vote, I think. And then let's continue with that topic, because it's an interesting one there as well. €4 per kilometer. I think your operator costs are more usually. But a fixed wing would be ideal for large areas or corridors, definitely. If you don't need the flexibility of a multi-rotor, then go with a fixed wing. Hydrogen fixed wings. There was a German company, I think Silent Wings. They, I think, had 7 hours of flight time on their hydrogen fixed. A company in the UK, we are consulting plans to go for 12 plus hours. They have some aerodynamic design already in place. They're currently on batteries and they're converting to the fuel cell now. So the target seems to be about 12 hours as the capability. Fixed wings are ideal for ultra long distance. Actually, for the multi-rotor, the world record is currently in South Korea, where a company used actually the same system we use, but they used liquid hydrogen, which is even more energy dense, and they did 12 hours with a multi-rotor. Imagine that. And of course, yeah, the parachute safety system is always needed. That regulatory or the clearances are much easier if you have it on board, especially if we're working outside in urban scenarios. And yeah, the output of the fuel cell usually is the same XT60 plug that you'd have from a battery. So you just change that and the battery plugs, the small hybrid battery plugs to the fuel cell. And the fuel cell outputs the power to the rest of the drone. So you don't need to make actually any changes in the rest of your architecture. You might need to design around a bit because batteries are easier to stack and hide in little compartments and nuggets and all of that. But the fuel cell itself is a fixed package. And then you have the hydrogen cylinder, which is round and long. So you have to sort of have a bit of a different design sometimes if you want to take the full efficiency, of course, of the system. Because we designed completely from the ground up, and I think we have 15–20% more efficiency because of that. Like we've tested in really high winds as well, in like 20-meter-second gusts. And the fact that you have a custom design around it actually makes it so that the wind rather helps with your flight time rather than restricts it in any way. But I think we're done with our poll. Yeah, there's been no new additions, so let's publish the results. You want to talk about mobility and aviation and integration there, which is one of my favorite topics, so well chosen. Feel free to add questions to that topic as well. But what's happened this year now was also the launch of the International Hydrogen Aviation Association. We were one of the first to actually be invited there, and the first expo took place also in September. It was supposed to be in Glasgow with the United Nations 2020 Climate Summit, but COVID. So it was virtual, but there was a lot of interesting going on there. And of course, Zero Avia, these guys are always great. They were doing their flights now in Cranfield in the UK with the first ever planned commercial hydrogen airplane, which is, I think, Piper class. So it's not yet big, but it's more like regional. But they plan to be commercial by 2023. So not too long to go. I did forget to add images of the Airbus's new designs, but you can look them up if you Google Airbus hydrogen. I think their earliest were supposed to be commercial by 2035, because decarbonizing aviation is not easy at all. You have to do synthetic fuels or hydrogen, because batteries, yeah, good luck. They've done a battery plane actually, great plane, but all you can fit is the pilot. So maybe not that important. So you have to have really high energy density there. The only problem with hydrogen is the mass of containing all of that. Because let's take type 4 cylinders, which are carbon, aluminium lined, for example. All of these, hydrogen itself only makes up about 6% of the entire weight of containing it. So if you put it at like 700 bar or 300 bar or whichever weight you need, then if you calculate your hydrogen consumption, which is also easy to do, you multiply 33.3, which is the kilowatt hour per kilogram ratio. You divide that by the efficiency, which is usually 60%. Then you have your number, which you use to divide your consumption. And from that, you find out what's your hourly consumption. So let's make a quick test. We have about 600 watts on average ourselves that we use. So multiplying 33.8, that's 19.98 is the efficient watt hours we get per 1 gram. So 600 divided by 19.98 is 30 grams per hour. That's our consumption. That's how easy it is to find out what you need. When you start integrating your own hydrogen, that's the way that you calculate what the system needs to be. If I want to have 2 hours, then I know that I have to have at least 60 grams of hydrogen. And hydrogen at 300 bar is 21.2 grams per liter. So I need 3 liters tank to contain that hydrogen that I need to carry for a 2 hour flight time. So it actually makes life easier when you need to do calculations. I've done those calculations for the hydrogen Cessna that we want to build in the nearest future, or convert, and we know what we need to do already. Estonian air quality related, no. Air quality is something that was interesting for us to hopefully explore in the future. But we haven't received or seen any projects related to that or that method of monitoring. I think it would be really important for smart cities, especially when frequent drone operations starts, to map air quality, because you get it from like this usual range, let's say 100, 120 meters, where you'd be flying at, operating at, so close to the airspace ceiling. That you can use, and if you monitor that air quality from that level, you'd take out the distractions from the traffic on the ground, because I've seen the usual sort of way discussed last year actually in a Finnish conference was to have air quality sensors on buses, on city buses, but then you're close together with the next one. So how do you find out what actual air quality is in neutral terms? So you should be having it a bit higher, I think, although of course you'd want to also know what it is at walking height. So what's actually the cancerous quantity of micro particles the person's breathing when he's walking around in a city. So it's an interesting topic, that's for sure. And to add to the mobility area, then in case for you who don't, there are also high bikes. I have the permission from the city of Tartu to go for a procurement of one of them. We want to have them, one at least for show and tell, basically. A hydrogen bike, as the rule with batteries, it can go 3 times further. So we have a 150 kilometer range on a hydrogen bicycle. So we want to get one for trials, testing, show, whatever. There's a company in France called Pragma that does them. I know that Hydrogen Europe also has one, so we might be getting one from there as well, but that would be a loan unit only, but we actually want to purchase one for here. So there's any type of vehicle that you can really imagine. We created one ourselves, which I showed you previously. But yeah, you can use it in any situation. There's currently a single Toyota Mirai registered in Estonia, and that's refueled in Latvia. So unfortunately, we've not been really that innovative here as a region in showing way in taking up these new energy carrier and mobility options. But when we're talking about shift to renewables and distributed power instead of this single plant somewhere polluting everything nearby, producing the most awful quality of dirty energy that's possible, when we distribute power with renewables, we need to store it. And we need to start thinking about seasonal storage. And where do you store it? And how do you store your energy that you produce in peak hours? For example, when we have now all the wind parks installed that we have projects for, we could take the power cable to land, but we can't connect this because it can't accept as much power. So we'd flush the grid, and of course we'd have to sell electricity, or not sell, we'd have to pay people to start using electricity, because during those peak hours we couldn't consume it. So we need to store, and also for winter months we need to store seasonal. And the best way to store it is in hydrogen, because batteries don't work for mass scale storage. And actually, let's take it one step further. There was an interesting seminar yesterday evening, really good one. And what I took, or actually what one of our colleagues took, was make some slides. I'll skip this one for now, but hydrogen myth busting, that's a great topic. And I'll show you some slides, I can share them, and I have the contacts of that guy that actually made all of that, put all of that together. So what you can see here is common myths, and just write in the chat the number of the myth if you want to go further into it. But I'll quickly scroll through some of those misconceptions and theories, and one of them is the battery solution. Now, the only way is to be electric in terms of mobility and transportation when we're talking about carbon neutrality targets. But whether you store the energy in batteries or hydrogen depends entirely on what your application is. How far do you need to go? How heavy is your vehicle? Because as I said, if it's in the air, then yeah, batteries are out of the question straight away. It's useless. But if you store in hydrogen, then you at least have a chance on decarbonizing that sector as well. And we talked briefly about fuel cell vehicles as well. And of course, as I said, hydrogen has been around for a while. The fact we haven't used it in Estonia means we don't have any industry that could have used it before. We don't do metalworks, we don't do ammonia production, neither of that. Actually, our industry for the past 20 years has been IT. I think that's pretty much it. And that's actually why we are quite behind in a lot of areas. So we have more to catch up. Here's another set. Overall efficiencies. Usually the calculation method is wrong as well. But at the same time, when we take our area, then an electric car and hydrogen car have the same efficiency. Because on a hydrogen car, the 60% efficiency, the remaining 40 is not lost, it's heat. And when you use that heat, you'd want to use that heat during winter. On a battery car, you have to generate that itself from the battery. So you consume all of that power just to have that. And that means that you end up with the same range, or actually not the same range, the same efficiency. A hydrogen car's range doesn't change during winter. An electric car, you divide by half. Whatever you had during the summer, you divide it by half for your winter. Or maybe it's going to be less now with global warming, who knows. So the efficiency is also how do you use it. If you can combine the heat and power, for example, in the UK, they're now installing hydrogen boilers everywhere because they have a massive gas network. They've always used gas for everything, but now they're decarbonizing the gas grid. So they're injecting more and more hydrogen into it. And eventually they want to go to 100%. So in the boiler, what you do, it's nothing fancy, same piping, all of that. In the boiler, you use the generated heat as heating, That's perfect. What you want is warm water anyways. And you actually produce your own water because that's the reaction, H2O. So you get free water basically from this system as well. So if you can use it, use it. And actually when you generate hydrogen, it's the reverse process. So what you do is you use water, but you generate oxygen. So in certain scenarios, for example, in space, it's quite useful. But if you'd want to argue then hydrogen vehicles or hydrogen deployment, PEM electrolyzers actually help generate additional oxygen because apparently our oxygen levels have been dropping as well over the years. And of course, cost and all of those topics. Let's see what the experts say. Oh yeah, that's the energy efficiency that I was talking about as well. And the production. Yes, to generate 1 kilogram of hydrogen, you need about 50 to 60 kilowatt hours of electricity. And 1 kilogram of hydrogen has 33, so you have a loss there. But if you can't use the power straight away, the energy you generate, for example, in Estonia, we already have to shut off half the windmills during those good wind days, because otherwise we'd have to shut down our electrical plants. We can't run two at the same time. We don't want to have our grid energy go into -2 or 4 euros, right? So what we have to do is shut them off. So when we have that excess power, let's save it. You could actually save it and sell it when cost is really high. So you could be making some money on the sideline. I think Tartu University was planning to do that. Again, some energy storage-wise, which we discussed already. The gas grid, once again, in Estonia, hopefully we can get past the legislative barrier of 0.1%. If we can have more, then that would be our storage, our seasonal storage. Fill the grid up and use it when you need it. So there's some interesting additional myths there. China, there's on the bottom right-hand side there. China versus Germany has been an interesting one, because the top of the R&D one, that's what Germany does, and China's just deploying. Was an interesting webinar there where a company was basically they had like 4 million or something kilometers driven by hydrogen buses alone, and they started 3 years ago. That's massive, and they've had no incidents. So what does that show? Do we need to do more testing or piloting? No, let's just do deployment. Commercialization is the key. That's how you advance from there. And that's how you support all of those activities. What you need to do is you need to drive the costs down by commercializing. Initially, solar panels were really expensive as well. But then we started to mass produce them, and now it's the cheapest form of energy. No other electrical generation method is cheaper. I think the same goes for wind, actually. So they've been dropping really fast, and renewable generations driving that up. And this is the contact info for that person, because I used his slides and didn't have time to do my own myth-busting ones. We do actually have some extra here in Estonia from a few ministers, or at least their advisors, who think that the hydrogen explodes instantly upon contact with the air, which is not true. Otherwise, we'd be exploding all the time. And some interesting ones. But yeah, feel free to ask. I think I'm taking up a lot of your time already. So unless you have any other questions, I should probably let you go on to other topics. Anything I missed out on, let me know. Or tell me you've heard enough.
It would be definitely interesting to hear you a little bit more. You had the poll, and you told that it's this tight choice, but can you tell a few words about like the next D and P topics as well?
Yeah, the the B topic is sad. Yeah, but not as sad as ministers saying the things they've been saying and making all of our diplomats want to change professions. But that's another thing. The other problem is that we've been sleeping for too long. So starting with B and actually D, they go together quite nicely. Because on the European side, for example, Netherlands have had almost every type of hydrogen mobility and application for the past 10 years. They started piloting buses in 2010 or 12 or something like that. I think buses were 12. They have hydrogen garbage trucks, a lot of boats. We know that we want the boat, hydrogen boat in Tartu as well, for example. This has been said. But when we can have it, that's another thing. So they have everything in place. They're talking about hydrogen islands, production. They can, because of that, join a lot of more projects in the EU, because we have the same IPCEI that I was talking about, important projects of common European interest, strategic value change. All of those things are happening. Our own company Skeleton, that we like to say is still Estonian, even though they were taken to Germany, because Germany was a proactive country in terms of the last strategic value chain rounds. When we had batteries, Germany was like, okay, yeah, supercapacitors and ultracaps, they are really important, because with batteries, we need to take advantage of regenerative power. We need to take advantage of renewables and all of those things, and that goes hand in hand. So we are doing a lot of projects. We can give you the automotive makers and all of this. Just come to Germany, open something up here as well. And now Skeleton is in Germany, and actually Skeleton recently got the contract with Wrightbus for hydrogen buses. So we can at least say that the Estonian technology is going to be running on future hydrogen buses. But there, European-wide, there's the entire strategy is in place. All the goals are set, and we have the targets, and we're going to be raising CO2 fines, and all of this is going up. So if we don't react to that, we're going to be paying a lot of money in fines. And at the moment, Estonia is, I think, 110th in the, let me quickly see and give you the link as well. I always like this map, the electricity map live. You can see the Estonia's current location in electricity production. This is not good for us. We need to improve it. So there's a lot of measures in Europe. Actually, oh, today the consumption is good. And even the production is quite good today compared to usual. So we have a nice windy day today, actually, that's why. But yeah, Europe gives a lot of money for projects that are green. We have even the Green Recovery Plan. So the amount of funds we receive depends on the projects we try to do with it. How do we take advantage? Because the strategy is there. Europe has fuel cell hydrogen joint undertaking, for example. They have about 265 projects all across Europe. In Estonia, we have 0, because we weren't there at the right time doing the right activities, so we could be taking part in these things. And because of that, we missed out on a lot of potential opportunities. But we still have a time or a chance. We have companies in Estonia that are doing it. We are one of them. Okay, there's 2 others, but we have more, and Skeleton. So we do have some know-how here already. And for example, Operail is looking really heavily into doing a hydrogen train for freight, which is really unique. Port of Tallinn is looking into the next ship to be hydrogen battery instead of diesel battery. We have these companies and different counties that are interested in taking part in those applications. I met the mayor of Võru last week in the Tartu Renewables Energy Conference, or whatever it is correctly in English. And they had an issue last year where they lost all power. Was not good. And they were just 2 weeks away from having the diesel generators hooked up, so I was well timed. And they were saying like, oh yeah, I wish there was a better option to have this off-grid security, that if we lose the connection to the rest of the country, then we are still safe. And I said like, yeah, hydrogen off-grid has been used for a while. It doesn't, it's much smaller than a generator. It doesn't produce noise or emissions or that massive heat or vibration. You can just leave it there and it will plug in when necessary. So I was like, oh, fantastic. So there are a lot of opportunities. And of course, here in Tartu, which I always like talking about, because in the beginning of the year, before COVID really hit us, I had maybe even 2 hours, maybe an hour's meeting with this city council. And I said, like, yeah, there's a fantastic project on the European side, which offers support for hydrogen adoption, hydrogen programs, all of these things. And they were like, yeah, okay, let's take part in that. So we wrote the project together with the city and the university, and we submitted it to their, unfortunately only 11 were selected, and Tartu was not amongst them because Estonia's strategy at that time was non-existent. Actually still is, but at least there's a proposal to have a hydrogen strategy nationwide as well. But Tartu is now an observer to those projects going on in the Europe side, which means a lot of good connections and interest and the potential, at least, to start doing things. And the plans themselves have not gone. In Tartu, we have all the stakeholders in place. Estico Energy already has a big solar park near or above their warehouse. They want to have hydrogen forklifts powered by the hydrogen produced by that solar park. And on the other side, we want to have a public hydrogen refueling station. Toyota has pledged actually to give us as many Mirais as we want here, which would be just rentals. You don't have to you don't have to buy the car or take care of it in any other way. You just rent it for a monthly fee, and you use it for the longest possible. So we want to have all of these activities launched as soon as possible. Of course, it would be good to have the government support as well. So the city doesn't have to cover 100% of the expenses, which they shouldn't, as long as they don't get the 100% that their citizens and companies pay to the state either. So hopefully there will be a nice program that we can join here as fast as possible. And even Tallinn has plans now to at least have a pilot project for a hydrogen bus or two with the refueling station. So let's see where that goes. Of course, in Pärnu, there's a station being constructed as well for ages already. But hopefully that will eventually get finished. So we do have things going on. And on the EU side, as mentioned, that the regulations are going tougher. Within a month's time, probably we will find out what the new transportation regulations are going to be. Because if I look at countries like the UK, who basically say that by 2035, I think, they will not allow the sale of any internal combustion engines, cars, new cars, none. And even like Jaguar said right away that, okay, we'll do a hydrogen Land Rover by 2030 then. So countries are making really strict statements. And of course, now for cities, Europe is looking for 100 carbon neutral by 2030 cities. I do hope that the political parties in Tartu will agree to this ambitious target, because those 100 cities will be peppered by projects and funding, of course, and advice and support and consulting and all of those activities. So let's take advantage of that. And any city, of course, can take part. I think at least 50,000 have to be living in it, though. I think that was the goal, to have these carbon neutral cities and targets. So we need to actually look at what Europe is doing and then make our own plans according to that. We are too small to make our own decisions or decide that we don't like this or that. This is for countries like Poland and Hungary, apparently, that can veto the European Green Recovery Fund, which was actually just done because some rules that they set there for sort of democratic government and democratic leadership was apparently not right for them. So they said, like, oh yeah, if you don't take that out, then we don't allow the funds to pass through, which is quite bad news for all the other countries. So it will be a tough negotiation, I think, to get them to agree and release those funds so that countries can start investing into innovation more. And hopefully here in Estonia also the ESA's new RUP, it's for different sort of research development and innovation sort of activities. Funding that can be used for these things. And of course, then you have Horizons, you have the Green Deal, Innovation Fund. There's a lot of opportunities on the EU side. I know that some are restricted because we don't have the infrastructure. For example, with the European Space Agency, there was a really interesting 5G project that we wanted to apply for, but we couldn't because Estonia was crossed off because we didn't have any 5G spectrum released even, or yeah, we still really don't to an extent. So some activities are restricted for us, but yeah, let's take advantage of them. Some ministries are already slowly getting on board. There are, of course, internal actors that for one reason or another don't really want to do that much work to catch up now because, yeah, of course, there's a lot to do as well. But it seems that things are heading in the right direction. And the more companies and people start making noise about it as well, the better it is, because otherwise they think it's the same as voting. If you don't vote, then can't complain later that, oh, why this guy? So we need to make some noise, and this will get our policy and legislation makers also acting, because they don't want to go against the grain either, because that would hurt getting back in the nice warm cabinet in the next year's time, maybe. So what else? No questions, so I can talk endlessly about these topics. Just throw me a bone and I will. And content, want any materials from my side, I can provide it, whether it's hydrogen related, whether it's drone related, whether it's whatever related. If it's within our expertise, then I'm happy to share.
But can you tell something about the environmental risks which are related to hydrogen? Like, if it will be anything has risk if it has very wide usage. So what would be the risks of hydrogen if it would become very common?
Well, hydrogen is really common, isn't it? It's the most common element in the universe. So there's no risk from the hydrogen part itself. It's all around us on Earth. I believe it's in the 6th place or something like that in terms of elements, because it doesn't really float around us in its free form, because it just flies out. So I think it's the only element that has to escape velocity to go outside the planet's atmosphere as well. So we kind of, it goes away when we release it, right? So there's no risk in terms of that, and it doesn't react, doesn't cause any problems with the ozone layer or something, anything like that. One of the things I touched on is now making those fuel cells large scale, right? So as I mentioned, usually for automotive, you need about 10 grams of platinum for a car's fuel cell. So one of the risks that was highlighted was that, oh, but we don't have this platinum. Where do we take it to, like, make all the better cars now, hydrogen cars? But we actually have it, because for every car we don't produce, petrol, diesel, they have the same, even double catalyst ones have even like 16 plus grams of platinum in them. So if we take out the catalyst, then in the car system that's usually cleaning the exhaust. If we take that out, then we have the platinum that we need to convert it to a fuel cell. So we actually have that resource already booked. For the other elements, yeah, they actually, it's not maybe always the good thing to bring out, but battery production itself is extremely bad for nature. And we don't really have that problem with fuel cells. Of course, each fuel cell should be a hybrid system, so we still need batteries, but we need less of it. Because with 1 ton of lithium takes about 500,000 gallons of water to mine. And the problem there is that that's usually done in areas like Chile and China and like I think Australia to an extent, and they don't have much water. So you're taking 2/3 of the water that people want to drink and using it for mining, and then Australia is on fire because you give all of your water to people mining on your territory. So that's a bit of a problem. I haven't heard of any real problems introducing fuel cells on a large, massive scale. Would introduce actually. You have the resources available. You need water to generate hydrogen, right? You need pure water, of course. So in terms of doing it on offshore rigs, offshore wind parks, you need to desalinate the water. You need to remove the other elements, but you don't need we have water. That's not the problem. I think we use it, and plus we regenerate the water later when we use that hydrogen. So it's the circle of life, basically. Main difference. I love this question. Hydrogen and methane. Methane, whether it's biomethane or fossil, is the same. The chemical composition is the same. The only thing we call it biomethane actually is the fact that it's produced from a renewable resource. Let's leave aside whether we could be using that field for something better or not. Biodiesel is an awful thing, really, because we take down forests to make it, right? But methane, fortunately, is not that bad. If we can generate biomethane from a byproduct, we can actually reach our carbon neutrality targets. So that actually solves that problem. The problem with methane of any kind, bio or regular or any sort of thing, is internal combustion. Methane is great if you use it in a hydrogen fuel cell, actually, or not a hydrogen fuel cell, if you use a solid oxide fuel cell. That can also use methane to chemically produce. So you can use actually methane in a safe way. But if you burn it, it's worse than diesel or petrol. It's only because of rules and regulations, or actually those standards, that don't force to count all the microparticles, that there's even a sort of clean concept of it, but it's internal combustion. So even if it's carbon neutral, it's going to be polluting. You bring the carbon to the city and you burn it, and you have microparticles that are cancerous, cause breathing problems, infection, whatever. It can be even more dangerous. But if you use it in a fuel cell, yeah, go ahead. If you combine methane with hydrogen, you can use it to slowly decarbonize, what the UK is doing already, and a lot of other countries. They're slowly decarbonizing the grid. So you go step by step. You introduce better, or you remodel your infrastructure slowly, because older piping, of course, they can't take a high percentage of hydrogen either. You're limited by like 5-10% of the entire range. But the new piping that's available, which is plastic fiber, it's actually 20 times cheaper than metal piping, so it's easier to deploy if we renew, for example, or if we have a new grid. So let's say offshore, actually bringing hydrogen on board or to the ground, to land, is 20 times cheaper than bringing it by electrical cables. Because you just lay a pipe, you can lay 4 kilometer segments at a time. So it's really easy to lay the pipe, and it's cheap. But that's that, yeah. And then on the ground, you can combine it with methane to decarbonize the grid, of course. But as I mentioned, I think Elering is still investigating Estonia's capabilities for hydrogen in the gas grid. So far, it's 0.1%, which is useless. But yeah, don't use internal combustion in any sort of application. That's where it needs to go. Otherwise, we can't go carbon neutral, and that's why they say that without hydrogen, we can't do it anyways, because you don't have the amount of batteries you need to have seasonal storage is massive. Hope that answers your question. And yeah, on the previous one, I don't know. Honest answer is I don't know what the highest risk with massive or large-scale hydrogen uptake is going to be. Because the platinum for automotive, we can take, it's a one-to-one shifts. We'll probably even have spare. So that can be solved. Okay, it doesn't maybe reduce platinum mining, but I think it's less risky for nature than, for example, with lithium and other. Cobalt is a main problem, actually, even worse than lithium, because that's done in Africa and there's a limited resource of that. So that might run out first, actually. So we need to hope that we have newer battery technologies coming out from the labs as well, because otherwise we'll have an issue with that at some point. And of course, it's the same for hydrogen fuel cells. There are actually other newer methods being worked on as well. Like the true boost has started maybe within the last 20 years, because now it's been used also for automotive and in a lot of other sectors. Previously, we had alkaline electrolyzers, which don't produce entirely clean hydrogen, which is necessary for proton exchange membrane fuel cells. So you can't combine those two. You can use alkaline fuel cells perfectly to produce the hydrogen that you need to mix with methane, for example, in the gas grids. That you can do, but not for proton exchange membrane fuel cells. That fuel has to be clean, the hydrogen. So it has to be really pure, not contain any phosphor or even excess water, ideally, because that's just going to reduce your output. And in case of phosphor, it will destroy the fuel cell or oxidize it. Yeah, I could probably show a slide even sometime because hydrogen is used in a lot of synthetic fuels as well. So you can produce synthetic methane from hydrogen, but it's not an efficient process. So unless you really need to, don't. Actually, Saudi Arabia, which has been really big on oil, if you look at the big trends, I'm not sure, again, going back to the government a bit, if you look at the oil companies that are shifting to hydrogen, and Saudi Arabia, which is an oil country, a rich oil country, and they're now building a 4 gigawatt solar park to produce hydrogen for green ammonia to ship to Europe. If those guys, and even Shell and all of those that have been always killing hydrogen in the past in order to sell more oil, and they're changing their pace, they're changing their story. They're all joining now in this new direction. And if those guys are making the decision, then is it fair for us to start calculating that is it viable for maybe a or something? That's useless. It's a question to have, even, because these guys have already done the calculations. Why don't you want to learn from others' mistakes or new opportunities? Why do you want to make your own? Like, it's waste of time and money to be calculating now, because with every year that we're behind, our companies and people are losing out on business, on innovation, on activities, on education, on the know-how. Like every year, 680,000 people die in Europe due to bad air quality. So I don't know what the figures are in Estonia, but whatever number of people That's the responsibility of the government to save, actually. Make the right shift. We can't get there overnight. It takes 10 years maybe before we see proper results. But we need to start yesterday. That's the main thing we need to start doing, is to move now, take advantage of that. And that also means that we can take advantage of the trends. Estonia actually could become a hydrogen exporting country because our solar, or not solar, but wind resource is so big that if we used it, we wouldn't need anything else at all, for one thing, but we'd still have to export 2/3, I think, of that, because it's we have a lot of resource in wind, and currently we haven't been using it yet. We have wind, I think the first ones start arriving 2027 offshore. Hopefully they will become a bit early as well. But Tartu is producing their 75 megawatt solar park as well, right? So we could be producing a lot of excess energy that we don't consume ourselves, that we could be exporting. This is why the port of Hamburg, for contact Tallinn, we are in a perfect corridor. This is why we had Netherlands-Estonian common seminar on a government level to talk about these opportunities that these countries have together, because we are perfectly in the right corridor. If you look at shipping lanes that go past Saaremaa, a lot of them, we could have a bunkering station there. We could be loading hydrogen one way or another way, or refueling hydrogen ships. So there's a lot of opportunities we could be using for big companies, for small companies, all of them. And when we look at our climate targets, I think the official percentage that we've saved 50% of our or reduced 50% our carbon gas emissions since the 1990s. If you look at this chart that we use always to promote that, oh, we've been doing a really good job. We've done 50% already, and we need to do 7% 2030. Oh, it's a really ambitious target thing. Yeah, but we actually need to do just 20%, because Estonia's history's largest contribution to reducing our greenhouse gas emissions was exiting the Soviet Union, because all of that 50% we did in the 3 years from 1990, because yeah, it's natural, of course. So we did all of that, and then at least 2018, we were at the exact same level as 2000 or 1995. So if anything, we've been increasing our emissions over time, or keeping them sort of level, fluctuating. So we haven't actually done anything yet in that respect. We just use an old event that happened as the baseline, which was interesting because Tartu unveiled their 2030 plans, Energy 2030, and they set the baseline as 2010, and to reduce the carbon greenhouse gas emissions, basically CO2 emissions, right? And that's a challenge because they've been increasing since then as well. And that's a really tough baseline to beat. But it's a good target. It's a fair target, and Tartu's actually plan. You can read that on Tartu's homepage. It's made public for consultation, actually, already a long time ago. Now they have the consultation figures as well. But Tartu plans to stop using fossil fuels or fossil gas in the municipal sector and in anything the city can control by 2030 completely. 30 gas is accepted. As mentioned, of course, if you burn it, then yeah, you're CO2 neutral on paper, but you bring that CO2 to the city, of course, and introduce all the other ones, all the lovely things that cause cancer. So that's why we need to think about what we actually do and how we progress. And this is why the shift to electrical is so important. And if you didn't know, then the first ever car was also electrical already. So we went in the right direction, and then we took the wrong turn. Of course, we need more power all the time. But of course, yeah, batteries couldn't take us very far, so we needed a different fuel, and fossil fuels were perfect for that. But now let's take the right turn and let's get in the right direction again. I think I'm running out of materials if you don't ask questions, so it's up to you guys. Surprisingly enough, I think there's still a lot of people still here. Ask anything.
I would stop recording, but then we can continue still asking questions.
Yeah, that's always fine for me.